we're going to continue to talk about wave properties, specifically wave speed. So wave speed is exactly what it sounds like. It's how fast the wave is going. So how fast a wave can transmit an oscillation, which is just one occurrence of a wave from place to place. So in our little picture here, we have a rock that is thrown into the water, and that rock causes a disturbance, which is a force that is applied to then cause the wave to move. And so in 1 second, it goes a certain distance. In 2 seconds, it goes twice as far. And of course, in 3 seconds, it goes 3 times as far. So we're wondering, how fast is the wave going? Waves do not accelerate. So this is a constant velocity or constant speed problem. And notice in all caps down here, the only way to change the speed is to change the medium. And the medium is just what the wave is traveling in. So for example, if you're sitting at a concert, you're not going to hear higher pitches first or lower pitches first. You're going to hear them all at the same time. They're going to come to you at the same time, same speed. But sound travels differently in different mediums. For example, sound travels slowest in air, but fastest in a solid. So only way to change speed is to change the medium. The first way to solve for wave speed is using just kinematics, what we did first semester. So V equals d over t. And don't forget that you can put this equation in your triangle with d on top and t and v on the bottom. Direct TV. So an example, what is the wave speed for a water wave that covers 1 meter in 5 seconds? So we're looking for speed, and we're given d and t. So we have 1 meter in 5 seconds, and so we get 0.2 meters per second. Most of your wave speeds are going to be in meters per second, so make sure you keep that in mind. Look at your units. Another way that you can solve for it is using the wave properties that we talked about in previous videos. So frequency, wavelength, period also. So the form where you have period, since period is 1 over frequency, it's just going to be speed equals lambda over period. So lambda being the wavelength, which is in meters. Frequency is in hertz, which is 1 over seconds. And of course, period is in seconds. And so again, you're continuing to get meters per second. So let's do a few examples of that one. If we have a wave that has a velocity of 250 meters per second and a wavelength of 6 meters, what is the frequency of the wave? And also, let's find the period. So we have V equals lambda F. We're given the velocity, which is our V. We're given wavelength, which is our lambda. And so we just plug in. So 250 equals 6 times frequency. And so we simply divide and get 41.7. Frequency is measured in hertz, so that is going to be our unit. Again, the velocity is in meters per second, and so our frequency is going to be in per second, which is a hertz. Our next example, we forgot to do period, didn't we? So for period, it's just 1 over frequency, so 1 over frequency. So 1 over 41.67 gives us a period of 0.024 seconds. Since it's hertz, 1 over seconds, the inverse is seconds. Our last example has a piano string tuned to middle C, vibrates with a frequency of 264 hertz, so that's our F. And assume the speed of sound is 343 meters per second. So that's our V. We're finding the wavelength. So V equals F lambda or lambda F. We have this one, 343, which is our velocity. We have our frequency, which is 264, and we're looking for lambda. So we simply divide again. 343 divided by 264 gives us a wavelength of 1.299.